Hi, I am Syed on Maths Online. Today's topic is ChiSquare Distribution. It is the second video on ChiSquare Distribution. In the previous video, we already seen few problems based on ChiSquare Distribution. We'll continue with few more problems in this session. I've already given you the formula for ChiSquare. So ChiSquare is written as summation of I is equals to 1 to n. It is OI minus of EI whole square divided by EI, where OI represents the observed frequency and EI represents the expected frequencies. Let us take few problems on this one. 4 coins are tossed 100 times and the following results were obtained. Fit a binomial distribution for the data and test the goodness of fit. ChiSquare at 5% level of significance is given as 9.49 for 4 degrees of freedom. Number of heads, that means 4 coins are tossed. How many times these 4 coins are tossed? 100 times. Each of the coin is tossed 100 times. So number of heads that you are getting over here is mentioned, and what is the frequency. So how many times you are getting the head, that is the frequency given. So this frequency that is given is called as the observed frequency. So observed frequency is given. What we need to calculate is, we need to calculate the expected frequencies using the binomial distribution. So this finding out the expected frequencies using the binomial distribution is nothing but test of goodness of fit. So let us use the binomial distribution and try to find out the frequencies, what we call it as theoretical frequencies. In one of my video I have already shown you how to find out the binomial distribution. You can refer that video also, or even in this video also I will be showing you how to find out the expected frequencies using the binomial distribution. So using these values of number of heads and frequencies, so I'll be taking this number of heads to be equals to x value and this frequency as f. So these are the values of x that you have, these are the values of f that you have. We know binomial distribution probability function. Binomial distribution probability function is given as p of x to be equals to ncx p power of x q power of n minus of x. So we need to find out the values of p and we need to find out the value of q over here. So for that we'll go for finding out the mean. So what will the mean mu from here? So the basic formula for mean mu will be, it is summation of fx by summation of f. So whenever the data is given in the form of x and f, you can use this formula, mean mu to be equals to summation of fx by summation of f. So summation of f into x, so you need to just multiply f into x. So the first value is 5 into 0 will be 0 itself, 29 times of 1 plus 36 times of 2 plus 25 times of 3 plus 5 times of 4 whole divided by summation of f. You need to just add the values of f. So it is 5 plus 29 plus 36 plus 25 plus 5. Just evaluate this one. So use your calculator and evaluate its value and see what you're getting. Check. I have just typed simplified and typed all the values and just check what is the solution you are getting. So that will be your required value. Just check, are you getting the same value there? So 1.96 I have got. So mean mu will be equals to 1.96. But what I require is, I require the values of p and q. So for binomial distribution, we know the value of mean mu to be equals to n times of p, right? So here, what is the value of n? How many coins are there? 4 coins are there, therefore the value of n will be 4 over here. So n is known, mu is known, so you can just plug in the value of mean mu over here. It is 1.96 is equals to n value is 4, so 4 times of p. So now we can just cross multiply 1.96 cross multiply divided by 4 will be equals to P. Therefore, the value of P will be equals to. So you can just use the calculator and just divide that 1.96 divided by 4. Just check how much you're getting. Are you getting 0.49? So 0.49. So the value of P will be equals to 0.49. Now we can calculate the value of Q. And you know the value of Q is always written in the form of 1 minus of P. Because you know that the value of P plus Q, the probability of success plus probability of failure will always be equals to 1. Therefore, the value of Q will be equals to 1 minus of P. So that is what I am using the result over here. So it is 1 minus 0.49. So just use the calculator and simplify it. Are you getting 0.51? 1 minus 0.49 will be 0.51. So you got the value of P, you got the value of Q. So you can just plug in this P of X value. We have P of X to be equals to NCX, that is 4CX. P power of X. What is P value? P value is 0.49 to the power of X. What is Q value? 0.51 to the power of N minus X, that is 4 minus of X. Right? So P of X value is obtained. Now for different values of X, you see the table, X value is 0, 1, 2, 3 and 4. What will be the theoretical, and we also call theoretical frequency as expected frequency. Theoretical frequency or expected frequency. So expected frequency can be written as capital F of X to be equals to. So it is total times of, you always get total times of P of X. So what is the total? Total is the frequency total. Is 5 plus 29 plus 36 plus 25 plus 5. You just add those values. So 5 plus 29 plus 36 plus 25 plus 5. That will be your total. You can just see the total is 100 over here. Because you are tossing 4 coins 100 times, so this total should also be equals to 100. So you got the total to be 100 now. So 100 times of P of X will be getting. So this will be equals to 100 times of P of X value is known over here. It is 4C X, 0.49 to the power of X, 0.51 to the power of 4 minus of X. But the values of X are known. For X is equals to 0, let us try to find out what is F of 0 value. It is 100 times of 4C 0 into 0.49 to the power of 0 into 0.51 to the power of 4 minus of 0. But you know that its value will be equals to, this is 100, 4C 0 will be 1, 0.49 to the power of 0 will also be 1. So you have 0.51 to the power of 4. You can just use the calculator and evaluate this value. You just check it. I've just typed in the values over here. This is the value that you are getting, the first result. So you can approximate and write the value to be equals to, that is 6.765. This is for X is equals to 0. So similarly you can write for X is equals to 1. So F of 1 will be equals, if you want you can take this as equation number 1. So just plug in X to be equals to 1 over here. We'll be getting 100 times of, it is 4C1 into 0.41 to the power of X is 1 there, 0.51 to the power of 4 minus of X is 1. So 4 minus 1 will be 3. So once again you can use the calculator and simplify this result. You just check out, just type the values, 100 into 4C1 into 0.49 into 0.51 whole cube is there. So just try to see the solution you're getting, 25.995. So you can approximate and write down the value. So it's 25.996. That will be the value. Now because we are finding out the theoretical frequencies over here, theoretical frequencies means, if you try to observe, we are trying to calculate the number of times head is occurring. So for that it should be a whole number. Number of times head is occurring, you cannot say 6.7. So you have to approximate to the whole number. After decimal, if the value is greater than 5, you can just cut off and add 1 to it. So for 6, if you add 1, it becomes 7. Here also 25.996 96. Approximately you can write this value to be equals to 26. So make it a whole number. Next, x is equals to 2. For x is equals to 2, you have f of 2 to be equals to. It is 100 times of 4c 2 into 0.49 to the power of 2 into 0.51 to the power of, it is 4 minus 2 will become 2. So once again you can just use the calculator. Just check, I have just typed the values. It is 100 times of 4c 2 into 0.49 into 0.49 whole square into 0.51 whole square. You just check, I'm getting 37.47. So we can approximate 37.47 can be approximated to 37 itself. Then go for x is equals to 3. So f of 3 will be equals to 100 times of 4c 3 into 0.49 to the power of x value over here. So x is 3 into 0.51 to the power of, it is 4 minus x is 3. 4 minus 3 will be 1. So that will be the value. So once again try to simplify this using the calculator. Again you can see I have just typed the values. You can just verify it. So 100 times of 4c3 into 0.49 whole cube into 0.51. So you just check the solution. You are getting the value to be equals to how much? 24 point something 000. So just make it as 24. So you got 24 point, you have 0004, or approximate that to 24. Similarly for x is equals to 4 you can evaluate. So therefore it is f of 4 will be equals to 100 times of, it is 4c 4 into 0.49 to the power of x value is 4 into 0.51 to the power of 4 minus 4 will be 0. So we have it is 100. We know 4c4 will be 1 itself, or you can use the calculator. This is 1. So 1 into 0.49 to the power of 4 will be so much only. 0.51 to the power of 0 will be 1. So just use the calculator for this one. Just see, I have just typed these values. Let's see what is the solution you're getting. 5.76 is there. Approximately you can write that value to be equals to 6. So we have got the expected frequencies or theoretical frequencies. So therefore you can write down the theoretical frequencies. Theoretical frequencies are, starting with the first value when x is 0, it was 7. Next you have 26. Next you have 37. Next you have 24. Next you have 6. So these are the theoretical frequencies. So the binomial distribution is complete. Now we will go back to the observed frequencies. Now this will be your expected frequencies. Let us use the ChiSquare distribution over here. Number of heads x you have, right? It is 0, 1, 2, 3 and 4. Your observed frequencies was 5, 29, 36, 25 and 5. This is already given in the table itself. Now what you have obtained over here will represent your expected frequencies. These values will represent the expected frequencies. That will be 7, 26, 37, 24 and 6. So using this expected frequencies, we will try to evaluate the ChiSquare distribution. So we know the formula for ChiSquare. The ChiSquare value will be summation of OI minus EI whole square divided by EI. So ChiSquare will be summation of OI minus EI whole square divided by EI. So which will be equals to, so starting with the first set of values of OI and EI. So OI minus EI whole square, that is 5 minus of 7 whole square divided by EI. Next set of values, it is 29 minus of 26 whole square divided by 26 itself, EI, plus next value 36 minus 37 whole square divided by 37. Next value 25 minus of 24 whole square divided by 24, plus 5 minus of 6 whole square divided by 6. So let us simplify. 5 minus of 7 will be minus 2. So minus 2 square will become plus 4 by divided by 7 as it is. So 29 minus 26 will be 3. So 3 square will be 9 by divided by 26 plus 36 minus 37 will be minus 1. But minus 1 square will become positive 1 by 37. 25 minus 24 will be 1. 1 square will be 1 by 24 plus it is 5 minus 6 will be minus 1. Minus 1 square will be 1. So 1 by 6. So you can just use the calculator and evaluate this value. Just see, I have just typed the values. This 4 by 7, 9 by 26, 1 by 37 plus 1 by 24 plus 1 by 6. Just check what is the value you're getting. So 1.15. So approximate and write down the solution. So you'll be getting 1.15 approximately. So chi-square value will be 1.15. Now we need to check this particular value with the value that is given in the question. So if you go back to the question over here, chi-square of 0.05's value is 9.49 for 4 degrees of freedom. Alright. Therefore, if you try to observe over here, is this value less? So this value is less than the value that you have 0.05 square. Its value is 9.49. So whenever the solution that we have got is less than the given value, we say that we accept the hypothesis. So here we are talking about the hypothesis of goodness of fit. Therefore, we can say that the hypothesis that the fitness is good can be accepted. Fit a Poisson distribution for the following data and test the goodness of fit given that chi-square for 0.05 is 7.815 for 3 degrees of freedom. So the values of x and f are given over here. So using this values of x and f, we will try to calculate the theoretical frequencies using the Poisson distribution. So we know the Poisson distribution formula. So Poisson distribution probability function can be written as P of x will be equals to, it is m power of x e power of minus of m divided by x factorial. This is the Poisson distribution here. P of x is equals to m power of x e power of minus of m divided by x factorial. So once again, using these values of f and x, we'll try to calculate the mean mu value. So mean mu will be equals to, it is summation of fx divided by summation of f. So you have summation of f into x value from here. So f into x, you just write down the first value, 122 into 0 will be 0 itself. Next value you have 60 into 1. Next 15 into 2. Next 2 into 3 plus 1 into 4. I just multiplied this f and x. So you got fx whole divided by summation of f. You need to add all these values, 122 f values. 122 plus 60 plus 15 plus 2 plus 1. You just use a calculator and calculate this value. You just see, I just typed the values, is simplified and type the values over here. You can just check your solution. So you're getting it is 0.5, or you're getting it 0.5. So therefore, the mean you got mean mu to be equals to. But for Poisson distribution, is nothing but m. So therefore we'll be getting the value of m to be equals to 0.5. So m value is known to us. So just plug in that value there. So therefore we have got p of x to be equals to m value is 0.5, 0.5 to the power of x. So e power of minus of m minus of 0.5 divided by x factorial. So you got the probability function of Poisson distribution p of x, but we want the theoretical frequencies. So therefore you can write down the theoretical frequency or the expected frequency. So theoretical frequency f of x will be equals to this total times of p of x. So you have to take the total of the frequency. So frequency total is given over here. So you need to just add this value 122 plus 60 plus 15. Just add and see what will be the value. So are you getting the 200? Just check it. So you're just getting the total to be 200. Therefore you'll be getting 200 times of p of x value. So that will be equals to 200 times of p of x value is 0.5 to the power of x e power of minus of 0.5 divided by x factorial. Or it is better you multiply this value e power of 0.5 into 200 and keep it. So what will be 200 into e power of 0.5? You multiply that value and keep that value separate. So separately I am calculating this value, that is 200 into e power of minus 0.5 and keeping this value ready. So 121.3, or you can approximate that value and write it as 121.3 into remaining values you can write it is 0.5 to the power of x divided by x factorial, right? So now the values of x that are there are 0, 1, 2, 3, 4. That is already given in the equation. So start with x is equals to 0. We'll be getting f of 0 to be equals to 121.3 into it is 0.5 to the power of 0 divided by 0 factorial. Anything to the power of 0 will be 1. This will also be 0. You will get back 121.3 itself. Alright, because you want to approximate, approximately you can write it as 121. So when x is equals to 1, so if I put f of 1 to be equals to, so if I take this as the equation number 1, in equation 1 if I put x as 1, so 121.3 into 0.5 to the power of 1 divided by 1 factorial. So here this will be 1 itself, 0.5 multiplied by 121.3. So check how much you are getting, 121.3 multiplied by 0.5. So are getting the value as 60.65. Just check, or approximately after decimal the value is greater than 1, so you have to add 1 to the previous decimal place. So therefore you will be getting 61. Next, when x is equals to 2 you can calculate. So f of 2 to be equals to, so 121.3 into 0.5 to the power of x value is 2 divided by 2 factorial, that will be equals to. So once again you can simplify this one. So you can just see I have just typed in there, it is 121.3 times of it is 0.5 whole square divided by 2 factorial will be 2 itself. So you can just check it. You are getting the value as 15 point something. You can approximate and write down its value. So you are getting 15.1625, or if you approximate its value will be 15 itself. Next go for x is equals to 3. X is equals to 3 will be equals to, f of 3 will be equals to 121.3 into it is 0.5 whole cube divided by 3 factorial. Our 3 factorial is 6. You can just use the calculator and simplify that result. Just check it. It is 121.3 into 0.5 whole cube divided by 3 factorial is 6. So in terms of the decimal you are getting 2.527. 2.5 if you approximate its value will become 3. So it is 2.527, or approximately its value will be equals to 3. Next, for x is equals to 4 we need to evaluate. So x is equals to 4. So we will be getting f of 4 to be equals to 121.3 into 0.5 to the power of x value will be 4 divided by 4 factorial. You can simplify this result. So you can just see I have typed 21.3 into 0.5 to the power of 4 divided by 4 factorial, or you can write it as 24 as 4 factorial anyway. So its value will be equals to so much, or if you write 0.31, so after decimal you are getting a value less than 5, so you cannot add 1 to the previous decimal place. So therefore this is because it is 0 point over here, and it is 0 point, this value is less than 5, so you cannot add anything to 0, so it will be 0 itself if you try to approximate the value. So it is 0.3159, or approximately you can make that value to be equals to 0. So we have got the expected frequency values or theoretical frequencies. So therefore we have the theoretical frequency. So starting from the first value, when the value of x is equals to 0. So when x was 0, we got it as 121, next is 61, next is 15, next is 3, next is 0. So 121, 61, 15, 3 and 0. Now put these theoretical frequencies in the table that is given in the question. So therefore, if you write down the table there, so you have the value of x, we write down the observed frequencies which is from the question itself. So x values you have 0, 1, 2, 3 and 4 observed frequencies from the table itself. 121, 60, 15, 2 and 1. So this is already given in the question. Now the expected frequencies, this is the values that you have calculated. So 121, 61, 15, 3 and 0. So here in the table, the last final value that is there, expected frequencies is 0 over here. So you cannot take the expected frequencies as 0, because you know the formula in the ChiSquare formula, you're getting summation of y minus of ei whole square divided by ei. So if you put ei as 0 there, anything by 0 will become infinity. So you'll be getting infinite solution. So therefore you cannot take ei. So you have to rewrite this table. Alright, so if you rewrite this table, in that case, so let me rewrite y and ei. So it is 122, it is 121, this is 60, this is 61, this is 15, this is 15. Finally these two values I'll try to add. 2 plus 1, this is 3 plus 0. So 2 plus 1 will become 3, and this is 3 plus 0 will become 3. So whenever anywhere you get 0 over here, you can just add either to the previous value of e or to the next value. So anything, but you have to avoid 0 in ei. So this is how I have avoided that 0 value, just by adding to the previous value. So now you can write down the ChiSquare distribution. ChiSquare will be equals to summation of oi minus ei whole square divided by ei. So it will be equals to, it is y minus ei is 122 minus of 121 whole square divided by ei is 121. Next you have, it is 60 minus 61 whole square divided by 61. Next value you have, it is 15 minus of 15 whole square divided by 15. The next value that you have is 3 minus of 3 whole square divided by 3 minus of 3. 3 minus of 3 divided by ei is 3. You can see that 15 minus 15 0, so this value will become equals to 0. 3 minus 3 0, this value will also become 0. You have to just simplify these two values. So 122 minus 121 is 1. 1 square is 1. 1 by 121 plus, this is 60 minus 61 will be minus 1. So minus 1 whole square will be plus 1 itself. 1 by 61. These two values are 0, you can ignore it. So just use the calculator and simplify this result. 1 by 121 plus You just observe I have typed 1 by 121 plus 1 by 61. Just check the solution that you are getting there. So it is 0.024. So you can approximate and write the value. So you got the value to be equals to 0.024 or 25. You can approximate and write down the value. So therefore this chi-square value which is there, now try to compare this chi-square value with the value that is given to us. It is 0.05 whole square. What is the value you got? 7.815. Compare these two values. Is this value less? So this value is less than 7.815. So whenever this value is less, what we can do? We can accept the hypothesis. Therefore, the hypothesis fitness is good, can be accepted. So whenever the calculated value what we have obtained is less than the given value, the hypothesis can be accepted. That's the required solution. That's all I have for today. Thank you.